So this says arithmetic sequences day 3, and we're going to do just part of these. Then we're going to also go into geometric sequences today. So arithmetic sequences day 3. Let's write out the explicit formula for arithmetic. It's a sub n is equal to a sub 1 plus the common difference times n minus 1. Now what it wants us to do is, given a term in an arithmetic sequence, any term, and a common difference, find the first 5 terms and the explicit formula. Well, it's going to be easier if we find the explicit formula first, then go back and find the first 5 terms, because we have to know term number 1 in order to perform the first 5. So we're using this formula, and we know this information. So what we know is we have our formula, a sub n is equal to a sub 1 plus the difference times n minus 1. We know the difference, yay. We don't know a sub 1. So that's what's really weird on this one. Now we do know an a sub n, and we do know n. So a sub n is 622, therefore n is 32. Because this says term number 32 is 622. So we can plug that information in. So in place of a sub n, we put in 622. We don't know a sub 1. We know our difference is 20, and we know that n is 32. So I'm going to pause, okay, see where we got all of that. We know a term in it. We happen to know the 32nd term is 622. So that goes in for a sub n. A sub 1 we don't know. We know the difference is 20, but we also know n is 32. Okay, so we plug that in. Now we're just going to simplify and solve for a. (20 times 31) is 620. We're going to subtract 620 from both sides, and we get 2 is equal to a sub 1. Okay? That is our first term. So our first term is 2. Now, that's our explicit, oh, wait, we didn't write the explicit formula. I'm sorry. Explicit formula, a sub n is equal to a sub 1 plus the difference times n minus 1. There's an explicit form. Now we could multiply that out and write it in simplest form, and I'm not sure what they want here. Let's just simplify it. It's better to be safe than sorry. Okay, so, and on the test we'll make sure that we're very clear on what we want. So let's simplify here. A sub n is 20n minus 20. So we get a sub n is equal to 20n minus 18. Okay, so there's our explicit formula. Now we have to find the first 5 terms. I'm going to do it just kind of an old-fashioned way as far as I'm concerned. I'm just going to write it out. Now I'm kind of out of space, but that's okay. My first term is 2. Okay, and notice that every single time I'm going to add 20. So I'm going to take 2 plus 20 gives me 22. And then I'm going to add 2 to that, and I get 20. What am I adding 2 for? Sorry, I'm adding 20. 20 is my common difference. Adding 20, I get 42. And after this, can't you just kind of see? I'm going to add 20 every time, so I get 62 and 82. There are my first 5 terms. Okay, let's do another one. And if you want to, just like we were doing in class, I do one, you try the next one, okay? So if you want to pause right now, I'll do the whole thing, but you can just do it on your own. Pause right now if you want to. So once again, we're going to use a sub n is equal to a sub 1 plus d times n minus 1. We know d is negative 8. We know that n is 18. And a sub n is negative 166. Because it tells us that specific term, a sub n is a term in the sequence. We can use that as our a sub n. So a sub n is negative 166. A sub 1 is what we don't know. Our difference is negative 8. N is 18. So we get negative 166. So we get a sub 1 is equal to 30. Therefore, we can write our explicit formula. A sub n is equal to a sub 1 plus the difference times n minus 1. That is one form of it. Let's go ahead and simplify it. So we get a sub n is equal to negative 31 minus 8n plus n. So a sub n is equal to 31. So we get negative 8n minus 23. That is our, wait, I can't subtract. Someplace I went wrong. Oh, I wrote in 31 instead of 30. Whoops. A sub 1 is 30, and I don't know why I wrote 31. Okay, so there is our simplified explicit formula. Let's go with our first 5 terms. I'm going to do it here. My first term is negative 30. My difference is a negative 8. So there's my first term. I'm going to subtract 8, negative 38. There's my second term. Subtract 8, negative 46. Subtract 8, I get negative 54. Subtract 8, oh, there's my, subtract 8, and I get negative 62. So my answers for my first 5 terms would be negative 30, negative 38, negative 46. I'm just not leaving myself enough room anymore. And negative 62. Okay, that's going to drive me crazy. I can't leave it there. Negative 30, negative 38, negative 46, negative 54, and negative 62. Those are my first 5. That is not the entire sequence. That's just my first 5. Okay, now let's look at a real-world problem. After a knee surgery, the trainer tells you to return to your jogging program slowly. He suggests jogging for 12 minutes each week for the first week. Each week thereafter, he suggests you increase the time, that's your big clue, increase your time by 6 minutes. How many weeks will it be before you are able to jog 60 minutes per week? Okay, so increase by 6 every week, that means that's my common difference. How many minutes am I starting off with? 12, so that's my a sub 1. Okay, now here's the other thing it's saying. After how many weeks will it be before you are jogging 60 minutes per day? Okay, that is my a sub 1, a sub n. That is my a sub n, because that's what I want to get up to is the 60. Okay, so now what we have to find out is it wants to know how many weeks will it be before you can jog that 60 minutes per week. That's going to be the term. We want to know where is that? What is n is what we're finding. So the question is, what is n? Excuse me. So obviously we're going to use the explicit formula. Okay, and let's plug in what we know. We know the first term. We know the difference. So there's our explicit formula. But we also know that a sub n is 60. What we don't know is n. That's the new thing that we haven't done yet, is we don't know what n is. We know what it's equal to, but we don't know what term number it is. So we're going to plug 60 in. Now we could have simplified it first, but we're going to go through and have to do all that work anyway. We'll just wait until do it now. Remember when I said solving equations is important and you need to be able to do it pretty easily? See how we just do it so much. Subtract 6. Divide by 6. 9 is equal to n. Okay, what does that n mean? That's exactly what they're asking us for, that it's going to be 9 weeks. It will be 9 weeks before to be able to run. It will be 9 weeks. It will take, oops, I should have said that. It will take 9 weeks to be able to run 60 minutes per day. Okay? So 9 weeks. Good. Now, there are notes on the back here. These are wonderful problems. And because we're a little shorter on time, and this is not included on the test, we're going to wait on this. And after we do systems of equations in Unit 3, we might come back to this problem. We're going to go right on to, oh, and the homework. You are going to do the homework. Okay, check with your teacher. You're only going to do the front side. Okay, so these notes we're not going to do. This assignment we're not going to do. Okay, going on to geometric sequencing notes. So another type of sequence that we'll work with this year is a geometric sequence. If a sequence of values follows a pattern by multiplying a fixed amount from one term to the next, it is referred to as a geometric sequence. So a geometric, you multiply. Arithmetic, you add and subtract. Geometric, you multiply. Arithmetic, you add and subtract. A fixed amount is called the common ratio. Okay, the common ratio, and we'll use the letter R for that. That's the common ratio. This constant common ratio causes a sequence to create an exponential function. And we'll get into that in another time. But remember when we graphed exponential functions, that's what's going to happen with these. Find the common ratio of each geometric sequence. In order to find the common ratio, remember if we did the arithmetic, we subtracted second term minus first term. Now we are going to divide second term by first term. And like we talked about last time, it just has to be two consecutive. So I can take second divided by first, or I can take second divided by first, or I can take second divided by first. You just have to have this one divided by the one in front of it. This one divided by the one in front of it. Okay? So if I were doing it second term divided by first term, I'd take 27 over 81. I'd reduce that down to lowest terms. I'm going to take the smaller ones because it's easier. I'm going to take 3 divided by 9, reduce that down to lowest terms, that's 1/3. So the common ratio is 1/3. Okay? We're going to do that same thing here. And again, if you want to pause yours at any point and try it on your own, that's great. We're going to take the second one, divide it by the first one. That gives us a positive 2 because I have a negative divided by a negative, so it's a positive 2. That's your common ratio. Now these notes are going to sound very familiar because we've done them before, except for we did it with arithmetic. The recursive formula is a formula used to find the next term of a sequence when the previous term is known. G sub 1 is the first term. Okay, so G sub 1 is the first term, but it's of a geometric sequence. Okay, G sub n is the nth term of a geometric sequence. G sub n minus 1 is the previous term in a geometric sequence. R is the common ratio. Okay? The recursive formula gives us two pieces of information. It always gives us the first term, and then it gives the pattern or the rule to get any sequence in given the one before it. Okay? These notes, exactly the same as they are for arithmetic. We do it differently, okay, but that's the only thing that's different. For this sequence, let's write the recursive formula. Okay? One of the things that you're going to be asked to do on the test is identify if it's geometric or arithmetic. So if I would try to find the common difference, 2 minus 1 would be 1. Can I take 2 plus 1 and get 4? So that tells you this is not an arithmetic sequence. This is a geometric. Okay, so let's find the ratio. The ratio would be second term divided by first term, so it's 2. Now let's use that ratio. Can I take 2 times 2 and get the next one? Yes. Can I take 2 times 4 and get the next one? Yes. So you see how you multiply to get the next term if it's geometric. To write the recursive formula, so G sub 1 is equal to 1. That's my first term. G sub n is equal to the previous term, G sub n minus 1, times the ratio, which is 2. Now, sometimes we will write this in a different order. So G sub 1 is equal to 1. That's the same. But G sub n, a lot of times we will write the number and then G sub n minus 1, meaning that we're multiplying right there. But we have to have that number in front in order to make sense. This is a subscript, remember. Okay, so let's try a few. If you want to, turn your pause yours right now and try it. So we found our common ratio is -2. Our first term was 3. And I wrote it in that different order, putting the number out in front. But it really doesn't matter. And remember, this is a subscript. Okay, let's try B and C. Go. So on B, we got G sub 1 was 2. G sub n was 2 times G sub n minus 1. Here our common ratio is 1/4. So our answer, remember, is this part right here. Then you plug it in. Our first term is 320. G sub n is 1/4 times G sub n minus 1. Or you can write it as 0.25 times G sub n minus 1. Good. Let's look at, if we want to find the first 4 terms. So notice how this can be written. And this is kind of a function notation. They're kind of referring to that. So it's kind of weird that we write it all of a sudden in function. It looks like it's a function notation, but it's really not, but it can be seen that same way. So if I want the first 4 terms, my first term is -2. What am I going to do to that? Oops, sorry. So my answer is going to go right down here. -2 is my first one. What I like to do is just follow what it says. It says you're going to keep multiplying by 3. So multiply by 3, and I get -6. Multiply by 3, I get -18. Multiply by 3, I get whatever 18 times 3 is. And I get a -54. Okay? Do the same thing here, except for now we're going to do 1/5. So I have my first term is 200. I'm going to take 200 times 1/5. And we all know that means you're just going to be dividing by 5, right? So 200 divided by 5 would give me 40, right? Now I'm going to multiply by 1/5. 40 divided by 5 is 8. How many terms? I need the first 4, so I have 4. Now I'm going to take that times 1/5. That's not as pleasant, but it's just a fraction. It's just 8/5 as your final answer. That's your 4th term. Okay, now of course you knew there was going to be an explicit form. The explicit formula is used to find the nth term in the sequence. It looks very similar to what we did before in a lot of ways. We're going to take the first term, but since we're in multiplication, we're going to multiply, and now it's to the n minus 1 power, and that's that exponential function that we come up with. So it's going to be a little more complicated, but not anything too bad. Okay, so we just have to pay attention to those, and we're going to probably use our calculator for those exponents. So for the sequence, let's write the explicit formula. So I have G sub n is equal to G sub 1, which is 1, times the ratio. We have to go over and find the ratio. Ratio is second term divided by first term. So it's times 2 to the n minus 1. Now here, that would just simplify down to be 2 to the n minus 1. Normally we couldn't multiply that out, but because it's 1, it's not going to be a big deal, so we can do it. A lot of times we'll just leave it in that form. Now that I think about it, we should just leave it in that form. This is not good practice. Not good practice at all. Okay? This is to the n minus 1 power.